Dear students, welcome to my YouTube channel PCM Academy and myself Pushit Moli. And we are in a lecture series on IIT Mathematical Physics. And in the last class I have discussed about Taylor series and the Maclaurin series. And now we are in a position to conclude our single variable task. Okay, the problems which are asked from single variable calculus. And the last topics today I will discuss about the maximum and minimum of function for single variable. And we will also discuss the maximum and minimum of function for two variables functions later on. But this is the last class of single variable function. Okay, now from the next class I will discuss about the more than one variable, that is several variable function, and I will start with the partial differentiation. Okay, so today basically I am going to start maximum and minimum of function for single variable. How you can check the function as a maximum value or minimum value, and where the function has a maximum value, where the function has a minimum value, what is the value of the maximum value of the function, what is the minimum value of function, etc. And you have already started this kind of situation in your 10+2 level. And the single variable calculus, most of the cases, the most of the part which are in IIT JAM syllabus, you have already studied in your earlier class. Okay, but the topics from there, I have chosen some important topics from where questions are asked, and I am giving you the basic concepts of this and one or two examples. Okay, so today I will discuss about maximum and minimum of function. Now to discuss these topics, let me choose a function which has maximum and as well as minimum, that you can understand the thing. Okay, so if I draw a function, okay, which is maximum as well as minimum like this. So let me choose a function. So this is y, you can say, or f of x, this is x. Now you can see a very obvious situation that at the maximum, you can see easily from this function that this is the point where the function is maximum value and this is the point where the function is minimum value. And you can see easily that at the maximum and minimum point, the slope of the function is parallel to x-axis. Okay, the slope of the function is parallel to x-axis. So if the slope of the function is parallel to x-axis, that means dy by dx is equal to 0 here, that is f prime x, or you can say f prime x is equal to 0 here, or f prime x is equal to 0 here, also for this point and for this point. So if the function is maximum or minimum at any particular point, if the function is minimum value or maximum value, then this is obvious that the first differentiation of the function, that is f prime x is equal to 0, or you can say dy by dx is equal to 0. So this is the first step to check whether the function is minimum value or the maximum value. Okay, so let me take this point is a, or maybe this point is b. Okay, so if f prime x at x is equal to a0, at x is equal to a0, then function has the maximum value, and if at b f prime x is equal to 0, the function has the minimum value. But initially, when you are asked to find out the maximum or minimum of a function, you cannot say only by using the first differentiation, because the first differentiation equal to 0, or the slope of the function at any particular point, if the slope of the function at any particular point is 0, then you cannot say the function has the maximum value or minimum value. You cannot say definitely that the function is maximum value and the function is minimum value, because both possibility are there. F prime x is equal to 0 means maybe it is maximum, maybe minimum. So what we have to do in that case, we have to take the second derivative of this function, and the second derivative means here actually, if you see geometrically, that the second derivative means that actually that if we take the change of this slope, okay, so if we take the ddx of dy by dx, what it means? Ddx of dy by dx means the change of the function slope, actually the change of the slope at this point with respect to x. So if we increase x from this point to this point, it never will point, the slope of the function will be like this, So this is nothing but actually the change of the slope of the function with respect to x, d dx of dy by dx. And you can see that this slope is nothing but the negative slope, because the angle which is made to the positive x-axis is greater than 90 degree, so it will be negative. So if d dx of dy by dx is less than 0, that means d2y dx2 is less than 0. Okay, then you can say that at that point the function has maximum value. The function has maximum value. But you can see here, if we change x in positive direction, of course, if we change x, then the slope will be like this, and which is positive slope. The change of slope is the change of the slope dy by dx is positive here. You can see from this point to this point, this is positive. So if this d dx of dy by dx is greater than 0, okay, that means that d2y dx2 is greater than 0, then you can say the function has minimum value at that point. The function has minimum value at that point. Minimum value at that point. Okay. So what are the steps to check the maximum, minimum, or to find out the maximum, minimum value? First, you have to make the f prime x is equal to 0 or dy by dx is equal to 0. Then you will get from here some point x is equal to x0, x1, etc. Now you have to take second derivative of this function. Okay, and for which point the second derivative is less than 0, you can say at that point the function is maximum value. And if the second derivative is greater than 0, then at that point the function will have minimum value. Maybe for a particular function, you can see from this figure both maximum and minimum value, and maybe for a function only minimum value and only maximum value. Maybe some functions which have no minimum and no maximum. Okay, now how we can check that kind of function? Sometimes you can see that f double prime x or d2y by dx2, that is the second derivative of the function, d2y dx2 will be 0 sometimes. So if d2y dx2 is 0 or f double prime x is equal to 0, then how can we check the function has minimum or maximum value? Then we have to check, you can see, we have to check f prime x. We have the only option to check f prime x. So we will get some expression of f prime x from f of x. And now what we have to do, we have to take some neighbor value of x. Okay, so if for some neighbor value of x, if the function changes its sign, okay, from positive to negative, you can see here function change from negative to positive if f prime x. What it means, if you can see in this direction, at this point, its neighborhood point, the slope is along this direction, this is the slope, but at this point the slope is this. Okay, so if we change the point, some neighborhood point where f prime x is equal to 0, of course, so with reference to that point, if we take two value, one value from here and another value from here, and if the function changes its sign from positive to negative, if the function changes its sign from positive to negative, then what will happen? The function will must have maximum value. Maximum value. I will give you some example, then you can understand. Okay. So it must have maximum value if it changes sign positive to negative. Okay. So in that case, it is a maximum value. I will take some example later on. Okay. And here you can see if the f prime x change sign from negative to positive, you can say. So what we have to do, we have to take points, neighborhood points with reference of that point where the f prime x vanishes. So if at the point x is equal to f prime x is vanishes, then we have to take 2 points. One is here and another is here. One is less than from this point and another is greater than of this point. And if we take this point first and then this point, and if the function changes sign from positive to negative, then what will happen? It must have the maximum value at that point. Similarly, here you can see if the point is less than, then the slope is negative, and if the point is greater than, then the slope is positive. So here the change of sign should be negative to positive. So in that case, if the f prime x changes sign from negative to positive, then we can say the function has minimum value at that particular point. But if the function do not change sign, then you cannot say that the function has minimum or maximum. So in that case, the function has no minimum, neither minimum nor maximum. Neither minimum nor maximum value. Okay. So this is how we can check. So first what we have to do, we have to take the first differentiation is equal to 0, and we will get some points. Now put the point in the expression of second differentiation of the function. If we get second differentiation is positive, then we can say what? The function has the minimum value, and the second differentiation is negative, the function has the maximum value. But if the second differentiation is vanished, then what we have to check? We have to check the sign of function f prime x. If f prime x changes sign from positive to negative, then the function has the maximum value, and if change negative to positive, then the function has minimum value. So this is how we can check for a particular function that either it has minimum value or it has maximum value. Okay, so let me take some example based on this theory. Okay. So now let me solve this question. Okay. The question is, find the maximum and minimum values of 3x to the power 4 minus 2x minus 6x square plus 6x plus 1 in the interval 0, 2. So here we can take f of x as 3x to the power 4 minus 2x cube minus 6x square plus 6x plus 1. So what we have to take first? We have to take the first differentiation, that is f prime x. So it will be 12x cube minus 6x square minus 12x plus 6. Okay, so this is the expression, that is f prime x, and this can be written as, you can easily take that, if we take common as x square, so it will be 12x minus 6, okay, minus 1 into 12x minus 6, so it will be x square minus 1. You can common 2 here, 6 also. So if we take common 6, then 6 into x square minus 1 into 2x minus 1. Okay, so now if we put that f prime x is equal to 0, if we put it at 0, then the x will have value, one is half and another is x square is equal to 1, so x is equal to plus minus 1. But we have to take only the value x is equal to 1, because the interval is 0, 2, so negative sign is not allowed. So x is equal to 1 and another is x is equal to half. Now we have to take second time differentiation, that is f double prime x, and if you take the second differentiation, then you will get 12 into, you can take from here also, that is, you can take common 6. Okay, so if you take common 6 on end of this, so 36x square minus 12x minus 12. So now if we take common 12, then it will be 3x square minus x minus 1. Okay, so it will be 12 into 3x square minus x minus 1. Now if we put x is equal to half, okay, so f double prime half will be 12 into 3 into 1 by 4 minus 1 by 2 minus 1, and you will get minus 9. Okay, we will get minus 9, which is obviously less than 0. And if we take f double prime 1, then it will be 12 into 3 minus 1 minus 1, so that will be 12, obviously greater than 0, that will be greater than 0. So here f double prime of half is equal to minus 9 less than 0. It means at x is equal to half it has maximum value, and at x is equal to 1 it has minimum value. Now what will be the minimum value and maximum value? You can put here and you will get the result. So the maximum value of f of x will be what? F of half. Okay, so if we put f of half here, we will get the result 3 into half to the power 4 minus 2 into half cube minus 6 into half square plus 6 into half plus 1, and you will get the result. Okay, the 2 7 by 16. Okay, and the minimum value you will get at x is equal to 1, and you will get, if we put on this expression as x is equal to 1, then you will get f of 1, and which will be 3 into 1 to the power 4 minus 2 into 1 cube minus 6 into 1 square plus 6 into 1 plus 1, and you will get the result, the 2. Okay, so this is the minimum value. Okay, and this is the maximum value. Okay, now let me take another example. Okay, so here the problem is that, so that sin x into 1 plus cos x is maximum when x is equal to pi by 3. Okay, so here let me take f of x is equal to sin x into 1 plus cos x. So it will be sin x plus sin x cos x, that will be half sin 2x, you can say. This is f of x. Now what is f prime x? F prime x is cos x plus 2 by 2 into cos 2x, so that will be cos x plus cos 2x. Okay, cos x plus cos 2x, and if we take this at 0, okay, so you can find f prime x is equal to cos x plus cos 2x, and if we take that f prime x is equal to 0, that means cos x plus cos 2x is equal to 0, and if you solve, you will get two value. So I can solve here, that is cos x plus cos square x minus sin square x is equal to 0. So if we take common cos x, so cos x into 1 plus cos x minus sin square x is equal to 0. And sin square x can be written as 1 minus cos square x also. Okay, so you can solve it. I think, let me give you the result directly. Okay, so x will have two value. You can see this thing as only the function of cos x, so you can write his sin square x as 1 minus cos square x. Okay, so you can solve these things. I will give you the result, that x is equal to pi by 3, and another we will get x is equal to pi. Okay, now let me take second differentiation. So f double prime x will be minus sin x and minus 2 sine 2x. Okay, so if we put that f double prime pi by 3, you can say, okay, so that will be obviously negative, because here you can say minus sine x plus 2 sine 2x. So you will get obviously negative, because sine pi by 3 and sine 2 pi by 3 is positive. So you will get obviously negative value. So it is a maximum at pi by 3. So obviously it is a maximum, has maximum at pi by 3. But what about pi? We know sine all pi is 0. So f double prime pi will be 0. This is the obvious condition, that f double prime pi is equal to 0. And if f double prime pi is equal to 0, then how we can tell the function is maximum or minimum? So we have to check the f prime x, the sign of f prime x, and if you put x less than pi, okay, x less than pi, and if we take x greater than pi, and if you put here, you will get both time negative. You can do, you will get both time negative. So what it means? It means that around x is equal to pi, the first derivative, that is f prime x, do not change sign. It means it have neither maximum nor minimum at this point pi, but it is a maximum at pi by 3. Though we have to prove this thing only, but you can check your theory, that theory part, when f double prime x is equal to 0. So here f double prime pi is equal to 0, and you can put x less than pi and x greater than pi, this expression, and you will get both time, you will get negative. And that means that the function f of x, that is this function, has neither maximum nor minimum at x is equal to pi.